Starting lesson 11.8, mastering three-dimensional figures. All right, we're going to bring it all together here from the whole chapter. Draw a rectangular prism and its net. Our rectangular prism. Oops. All right, here's a rectangular prism. There's so many different ways to draw this. Here's just one example. And if I wanted to draw the net of that, it would look something like this. So I'm going to keep the front of it where it's at. I'm going to open the right side up, and I get that. And open the left side up, and I get that. Then there's the back side attached to the right side. And then here's the top, and here's the bottom. All right, there's my net. All right, then there's the surface area formula. So it's 2 times, you could say the front, because the front and the back are the same. And that'll be the area. Let me make that a bit more clear. I would say the area of the front. Oops. Area of the front. All right, plus 2 times the area of the right, plus 2 times the area of the bottom or the top. All right, because they're also the same. All right, then there's the volume formula. Very simple volume formula. It's area of base times height, or also length times width times height. But the beauty of area base times height is that it could be applied to other three-dimensional figures. All right, going on to number 2, draw a triangular prism and its net. A triangular prism. All right, we're going to draw a triangle on the top, make it a bit slanted, because we want to give it that three-dimensional feel. Oh, I just realized I didn't add dashed lines to the previous example. All right, you have a ruler, you could be more precise. All right, going back to number 2, triangular prism. All right, so we're going to draw the net now. So I'm going to keep the front where it's at. I'm going to open up the right side. I'm going to open up the left side. Then I have the top, and I have the bottom. All right, the surface area formula is equal to 2 times the area of the bottom, because the area of the bottom is the same as the area of the top. Then I have plus, I'll just say the area of the front plus the area of the back right plus the area of the back left. All right, there's no precise way of stating the surface area formula. You just have to break it down into all its faces and find the area of all of them. So this is just one example of how you would state the surface area formula. All right, then we have the volume formula, which is, since it's a prism, we have a parallel bottom and top base. We have area base times the height. All right, let's go on to the next figure. All right, draw a cylinder and its net. All right, so we start off by drawing an oval, 2 vertical lines, then draw half an oval, and then make the rest of it dashed. All right, now to draw the net, what shape do we have going around the cylinder? We have a rectangle. All right, then we have a circle and another circle. All right, what is the surface area formula? Well, let's see here. We have 2 circles. So area of a circle is pi r squared, and there's 2 of them. All right, then we have this rectangle here. Well, we have the height. And then what's this distance here? Once again, that length wraps around the circumference of the circle. So the area of the rectangle will be the height times 2 pi r. And there is your surface area formula. You should know how to derive it. No need to remember it. Then you have the volume formula. Once again, area base times the height. For 4, draw a regular pyramid and its net. All right, pyramid. So we're going to draw a slanted triangle. All right, then I'll draw another line. I got that. All right. And then I'm going to have something like this, dashed line, dashed, dashed line. All right, there we go. There's our pyramid. All right, the bottom is a square. And then I have triangles around it. So if I open it up, it looks something like that. All right, the surface area is equal to, well, whatever the area of the base of it is, plus how many triangles surround it. In this case, 4, so it's 4 times the area of the triangle. All right, once again, you don't have to memorize the formula. Just derive it yourself. All right, and the volume formula is area base times the height, but we have a number in front. It's 1/3. All right, for 5, draw a cone and its net and state both the surface area and volume formulas for it. So here's a cone. We start off drawing a triangle, but we don't draw the bottom segment. We draw half an oval, and then the rest is dashed. Okay, so now if I open this up, I'm going to have to slice it down along the side here and open it up. And when I do, get like a Pac-Man figure. And then I have the base, which is a circle. All right, so there's my net. Now what's the surface area formula? All right, this takes a little work to derive, but you could use the knowledge you gain from figuring out the area of a sector to figure out this formula. But here it is. We have pi r squared for the area of the circle. And then to figure out the lateral area, it's pi RL. Then you have the volume formula, which is area base times the height. But just like a pyramid, it's 1/3 the area of the base times the height. All right, for 6, draw a sphere and state both the surface area and volume formulas for it. All right, here's a sphere. Start off drawing a circle. And they're going to draw half a circle or oval horizontally. Make the rest of it dashed. All right, and then here's your radius. All right, and state both the surface area formula. The surface area formula is 4 pi r squared. And then for volume, it's pretty easy. If you remember the surface area formula, it shouldn't be too difficult to memorize the volume formula. You have pi r cubed because you're working with volume, and you also take that 3 and you divide the 4 by it. All right, see those relationships there? If you see the connections, then you'll always remember the formulas. It's about making the connections. All right. For 7, draw a regular pyramid on top of a rectangular prism. State the surface area and volume formulas for the solid. All right, let's draw a pyramid now. On top of a rectangular prism. All right, so I got something like this. All right, yours should be much nicer than this. Okay, so state the surface area and volume formulas for the solid. All right, the surface area of this, what is it? I have the area of the base, the bottom of the prism. Then I have 4 times the area of the rectangles that are surrounding the rectangular prism. And then I have 4 times the area of the triangles. All right. Since you can't touch the top of the rectangular prism, you don't count that. Since you can't touch the bottom of the pyramid, you don't count that. And then I have the volume formula, which is area base times the height for the rectangular prism, plus 1/3 area base times the height for the pyramid. All right, for 8, draw a cone on top of a cylinder. All right. So let's see, what do we have here? To figure out the surface area, all right, let's start with a cylinder. Now for a cylinder, it has a top and bottom circle, but I can only touch the bottom circle. So that's pi r squared. Then I have plus, there's the lateral area of the cylinder, which is h times 2 pi r. And then there's the formula for the cone. Now I can't touch the bottom of the cone, so I'm not going to incorporate pi r squared, only the lateral area. What's the lateral area formula for a cone? Pi r L. All right. And then there's the volume formula. Well, what's the volume for a cylinder? Area base times the height. For a cone, it's 1/3 area base times its height. Okay? And these are different heights here. All right, I'll indicate that. Alrighty, that's all there is to that. On to the next. Draw a hemisphere on top of a cone. On top of a cone. All right, here we have a cone. And here is a hemisphere on top of it. All right, what is the surface area formula? All right, so surface area. All right, we have a cone. I cannot touch the circle from the cone, just the lateral area, so that's pi r L. And then I have half the surface area for a sphere, so I have 4 pi r squared. If I take half of that, it's going to be 2 pi r squared. All right, then for the volume formula, I have 1/3 pi r squared times the height, or 1/3 area base times the height for a cone. And then I have half of 4 pi r cubed for the volume of the hemisphere. That's all there is to that. And you could simplify this, but as long as you have the general idea. So it's going to be 2/3 pi r cubed. Let's just polish this up real quick. Okay. And then for number 10, draw a rectangular prism with a smaller rectangular prism cut out vertically from the middle of it. State the volume formula for the solid. All right, so you have a prism here. Then you got this, this. Okay. Then I have this. All right, there's the prism that was cut out from it vertically. All right, there it is. All right, so you have the volume is equal to the volume of the big prism minus the volume of the small prism. All right, that's all there is to it. And we are done. If you have any questions, make sure to ask.